Just when you thought things couldn't get any better, Tesla has been at the forefront with their groundbreaking electric motors, which have been hailed for their unmatched performance lifespan and low maintenance design. Tesla has once again stretched the bounds of what is conceivable. Let's talk more about these topics, but first, show your support for Wall Street Gains by hitting that like button. Elon Musk recently unveiled Tesla's newest motor, which has already begun to cause havoc in the industry. It's time to see how this revolutionary drive unit promises to change the industry forever, undoubtedly revolutionizing the way we think about electric transportation. And the button to subscribe, Tesla has been creating its drive units since its inception as Tesla Motors, under the leadership of Elon Musk, who has served as the company's product architect from the start. With the release of Tesla's model in 2012, the drive unit was brought fully in-house and no longer relied on licensed technology from third parties. This was made possible by Tesla's innovative approach to engineering and manufacturing, which has allowed it to maintain its leadership position in the industry. The original Roadster, designed nearly 20 years ago, contained power electronics in a drive unit that was built and designed by Tesla, but licensed technology from AC Propulsion, which was the proof of concept at the time. Two of the most sophisticated and effective electric motors available are Tesla's induction and permanent magnet motors. Developed by Nikola Tesla in the 1880s, induction motors are still among the most popular electric motors today. An induction motor's design is relatively straightforward, with fewer moving parts than other motor types, making it incredibly dependable and low maintenance. An induction motor generates a rotating mechanical energy by means of a series of electromagnets that create a rotating magnetic field, which in turn induces an electric current in the motor. Conversely, a permanent magnet, unlike induction, motors use a number of magnets to produce a magnetic field that interacts with the rotor and electric current to produce motion. PM motors are perfect for use in electric vehicles where dependability and fish agency are essential, since they have a fixed magnetic field, which increases their efficiency and reduces heat production while in use. For its Plaid vehicles, which include the Model S and Model X Plaid as well as the Tesla Semi, Tesla has also created a new kind of motor. This motor promises to push the envelope of what is feasible even further, and we're excited to see what Tesla has in store for the direction of electric transportation. Building high-quality products at a low cost requires a lot of work, but it also means that more people will be able to access and use Tesla's technology. Tesla has always been a company that innovates on features that are visible to customers, like power acceleration and low energy consumption or efficiency. However, one of the most significant innovations that frequently goes unnoticed is cost. Since Tesla must charge enough to cover all of its expenses, improving the factory is another crucial component of lowering the cost of the motor itself. At Tesla's recent Investor Day, car specialist Cindy Monroe and his team noticed that Tesla is using a hairpin electric and remains motor design, which further improves efficiency and lowers cost. Tesla has already been reducing costs in their Model 3 motor, which, despite the name being used in all of their vehicles, between 2017 and 2022, they reduced rare earth metals by 25%, removed 20% of the weight, and reduced the factory size for building these motors by an astounding 75%. Because this design used rectangular wire rather than the more conventional round wire, more copper may fit in the same amount of area, making the motor more efficient. All things considered. In contrast to traditional electric motors, hairpin motors are a relatively new technology that has been gaining traction in the automotive industry. Tesla's focus on extreme scale and cutting costs while maintaining high-quality products is truly innovative and game-changing in the automotive industry. By decreasing wind resistance and enhancing heat dissipation, hairpin motors' hairpin-shaped stator windings boost efficiency. These windings also enable a higher copper fill factor, which produces a stronger magnet and, consequently, a more potent motor. Tesla recently joined a number of well-known automakers like Volkswagen, BMW, and General Motors that have previously incorporated hairpin designs into their electric cars. And compared to competing software, Tesla's proprietary software is quicker and more precise, enabling them to rapidly cycle through millions of designs to select the best one. This program is particularly ideally suited for hairpin technology because AI can be used to optimize the motor's overall efficiency is increased and resistance is decreased by the hairpin winding arrangement. The precision of the copper hairpin bending and welding process is one of the main obstacles to the adoption of hairpin technology. In order to solve this problem, Tesla has created automated machinery that is currently in use for manufacturing these motors. This is a significant advancement because improperly welded hairpin ends can result in electrical losses that lower the motor's efficiency. Innovation is also included in Tesla's charging chip. Tesla develops its high-level guidelines internally and in consultation with specialists. An important technological advancement, Tesla chips are unrivaled in the industry because they have been able to reduce heat by 2 times and the number of microprocessors from 4 to 1, making the chip smaller and requiring less costly material and silicon carbide. Despite these changes, the chip still has the same, if not better, capabilities. At Tesla's Investor Day, the company was able to push the limits of what is feasible in the electric vehicle sector thanks to its dedication to software design and vertical integration. Colin Campbell highlighted their capacity to manufacture all 100 of their high-level vehicle components internally within an organizational framework that encourages participation and communication from all parties involved, including non-technical people. Based on its Silicon Valley origins, Tesla designs its hardware using software. The revelation that Tesla's next-generation motor will require no rare earth metals was one of the event's most striking disclosures. This has led to considerable concern in the rare earth metal sector as the stock prices of businesses such as MP Materials have declined. Tesla's engineering prowess is demonstrated by their ability to eliminate these pricey and challenging to source materials without compromising performance. Tesla had previously used 500 grams of an unidentified rare material and 10 grams of 2 other metals in each drive unit. However, the metals were not identified. These metals, which are normally found in Tesla's permanent magnet motor and cost more than $100,000 per kilogram, or more than $100,000 per ton, were neodymium, praseodymium, and dysprosium. In the long run, Tesla will save hundreds of millions, if not billions of dollars by eliminating rare earth metals. Additionally, hairpin-shaped stator windings will be used in Tesla's next-generation motor, increasing efficiency through better heat dissipation and less winding resistance. Companies like Volkswagen are still researching this technology, but the hairpin windings also enable a higher copper fill factor, which means more copper can be packed into the same space to create a more potent magnet and consequently motor. General Motors and BMW have already integrated this technology into their electric cars, and Tesla is doing the same. Sue? Tesla has been able to optimize its motors and cut expenses in other areas thanks to its dedication to software design. Compared to other competitors, Tesla's proprietary software enables them to model and simulate the complete motor and its rotating electric field more quickly and precisely. This makes it ideal for hairpin technology, which is still in the research stage. Additionally, Tesla manufactures its high-level chips in-house and has been able to reduce the amount of silicon carbide used by 75%. This reduction in chip size may affect multiple types of chips that the motor uses, but Tesla has also been able to reuse the inverter casings for all of their vehicles, allowing for interchangeability. AI can also be used to optimize the hairpin mining pattern to lower the motor's resistance and improve its overall efficiency. All things considered, Tesla has been able to push the limits of what is feasible in the electric vehicle sector thanks to their dedication to vertical integration, software design, and innovation. Although there are issues with Tesla's current design, Sandy Munro and his team believe that the next generation powertrain will enable Tesla to reduce costs and reconfigure its components. The total cost of the next generation drivetrain will be just $1,000, which is substantially less than what their rivals charge. The battery size used in this calculation seems excessively large, given that the next generation vehicle will be smaller and lighter. Hedgehogs responded that a 45 kilowatt hour pack is more accurate, resulting in a powertrain cost of $41,100 and a vehicle cost of $16,000. Sam Corris from ARK Invest estimated that a battery pack from the next generation vehicle could cost approximately $5,200 plus $1,000 for the new powertrain. What's remarkable about Tesla is that they can produce everything with themselves, which distinguishes them from their rivals who are busily outsourcing software and parts to close the gap. This closes the video. Thank you for watching all the way through, and we'll see you in the next one. Tesla's next generation motor will be on exhibit even more, and this design will probably become the standard for the majority of their vehicles.